Hi, this is section 5 of our Maths Olympiad training course, and this video will be about a review of trigonometry. So instead of doing the theory for trigonometry, which is pretty elementary, what we'll do is we'll discuss some nice problems, and through the problems, we'll revise all the techniques and concepts that you need to be familiar with. So let's begin. This is question number 1. It says, let A, X, and Y be real numbers with X and Y belonging to the interval minus pi by 4 to pi by 4 such that x cube plus sine x is equal to 2a, and we have 4y cube plus sine y cos y is equal to minus a. We have to find the value of cos of x plus 2y. Find the value of cos of x plus 2y. So you should try out all of these problems before you see the solutions. So why don't you take the time right now to try the solutions? You can pause the video, and after that, I will discuss the solution. You can understand what technique we are using here. So let's get to the solution. Here, we have a, x, and y be real numbers. X and y belongs to this range, and we are given two equations. X cube plus sine x is 2a, and 4y cube plus sine y cos y is minus a. So first thing that I can notice here is I can write this as 4y cube plus half of sine of 2y, right, is equal to minus a. And if you rework it a little bit, it becomes 8y cube plus sine 2y is equal to minus 2a, right? So this is one equation, and the other equation is x cube plus sine of x is equal to 2a, right? Now what we can see here is this is also 2y cube plus sine of 2y is equal to minus 2a, and this is x cube plus sine of x is equal to 2a, right? So that suggests to us that both the left-hand sides here and here are of the same form, and we can say define a function f of t which is equal to t cube plus sine t, right? T cube plus sine t, so that this equation becomes f of x is equal to 2a, and the other equation, the second equation, becomes f of 2y is equal to minus 2a, right? So what we are doing here is we are identifying that the identities are so close to each other. They look very alike. And here we have f of x on one equation and f of 2y on the second equation, right? And both of them are equal to 2a and minus 2a, right? What is the advantage of doing that? We can look at this function and analyze the properties of this function. We can see clearly that f of t is an odd function because sine is odd and t cube is odd function, right? So therefore, f of minus x will be equal to minus of f of x, right? Great. So if you notice that, you will realize that we can say that f of x is equal to negative of f of 2y, right? Here, f of x is equal to negative of f of 2y. F of x is equal to negative of f of 2y because both are equal to f of x is 2a and f of 2y is minus 2a, right? Now, negative of f of 2y is basically f of minus 2y, right? We have f of x is equal to f of minus 2y. Why? Because this is an odd function. So minus of f of x is equal to f of minus x, right? Now, another thing that we can notice here is that this f of t function is monotonically increasing. The f of t is basically t cube plus sine t, and t cube and sine t are both increasing functions on the interval minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. Now, if you notice, y belongs to this range, minus pi by 4 to pi by 4. So obviously 2y will belong to what range? 2y will belong to minus pi by 2 to pi by 2. So here, when you look at f of 2y and f of minus 2y, the 2y in that is in this range, which is minus pi by 2 to pi by 2. and x is anyway inside minus pi by 4 to pi by 4. So what we can say for sure is that f of x and f of 2y are both increasing in this interval, right? Both increasing because they are falling in the monotonic range of the function, the range of the function where fx increases. If you have an increasing function and you are given f of x is equal to f of minus 2y, that implies that x is equal to minus 2y. I hope you understand this point. For an increasing function, a graph of a function is like this. If the value of the function, actually, if there are two different points x and y, the value of the function can never be same, right? One of them is lesser than the other, right? But here what we have is f of x is equal to f of minus 2y. That implies, since it is an increasing function on this domain, that x is equal to minus 2y, which implies that x plus 2y is equal to 0. And therefore, cos of x plus 2y will be equal to 1, right? So actually, this problem is less about trigonometry and more about identifying that you can look at these two equations and see that it's basically one single function. And that function is increasing on this interval. And therefore, we can make a claim that if f of x is equal to f of minus 2y, x must be equal to minus 2y. So that's the solution for the first one. The value of cos of x plus 2y is becoming 1. Now let's go on to the next one. Question 2 says that suppose the least period of f of x equal to root 3 sine wx cos wx minus cos square wx. Cos square wx is pi by 2, where w is greater than 0. Basically, the least period of the function is pi by 2, and in a triangle ABC, with small a, small b, small c being the sides of the triangle, we have b square is equal to AC. We have b square is equal to AC. We have to find the range of f of capital B. Now here capital B, as usual, capital A, capital B, and capital C are the angles of the triangle. Are the angles of triangle ABC. We have to find the range of values of f of B, right? F of capital B. So in order to do that, we have to first identify what this function is. So this simplification is pretty straightforward. We can write this as root 3 by 2. 2 sine wx cos wx becomes sine of 2 wx. And we can write this cos square wx as 1 plus cos 2 wx by 2. And this can be simplified now as root 3 by 2 sine 2 wx minus cos 2 wx by 2 minus half. And by a simple identity, we can write this part as cos pi by 6 and sine 2 wx and sine pi by 6, which is half, into cos 2 wx. So this becomes sine of 2 wx minus pi by 6 minus half. That is my function f of x after simplification, right? If f of x is this, the period of f of x would be 2 pi by 2w, because 2w is the constant term that is multiplied with x. The least period would be the period of the overall sine function, which is 2 pi divided by 2w. So the period of this is coming out to be pi by w, but in the question it has been given that it is pi by 2. Therefore, w must be equal to 2. And therefore, we get a complete understanding of the function f of x. F of x becomes basically sine of 4x minus pi by 6 minus half, right? Now, if f of x is this, we have, in this question, we have been given b square is equal to AC, right? So let's try to use that. So if I use cosine rule, cos of b must be equal to c square plus a square minus b square by 2ac. Now, this can be written as c square plus a square minus ac by 2ac, right? And this can be written as greater than equal to, using A and GM on C square plus A square, we can write it as 2CA minus CA by 2AC, right? So we have cos of B is greater than equal to CA by 2CA, which is equal to half. How did I get that? By cosine rule, I have this. I use the fact that B square is equal to AC because that is given in the problem. And then I used cosine, A and GM formula, A and GM inequality, to say that C square plus A square will be greater than 2CA, right? So I'm getting cos B is greater than equal to half, which implies that B should be belonging to the set 0 to pi by 3, right? 0 is not included because 0 cannot be the angle of a triangle, right? So B belongs to this set. And now we just have to find the range of f of B, right? F of capital B. So now let's think about that. We have already simplified our f. So since B belongs to this range, f of capital B will be equal to sine of 4B minus pi by 6 minus half, right? Now, what is 4B? 4B will belong to 0 to 4 pi by 3. And therefore, 4B minus pi by 6 will belong to basically minus pi by 6 to 7 pi by 6, right? Minus pi by 6 to 7 pi by 6. And if you take the sine function, sine of 4B minus pi by 6, that will have, the values will go from minus half to 1. It will be equal to minus half when you get to 7 pi by 6, right? 7 pi by 6, sine of 7 pi by 6 is sine pi plus pi by 6, which is minus half. So this is the range of values of sine of 4B minus pi by 6. And our f of B was, you have to subtract half from it. So the range of f of B belongs to, when you subtract half, you get minus 1 to half, right? So finally, our answer is the range is minus 1 to half. And the way we got it is simplifying the initial function f of x and then using B square is equal to AC condition to figure out a range for the angle B. That we did by using cosine rule on triangle ABC and using EMGM as well. So we got cos B is greater than equal to half. This is the key step of the problem because it tells us the range of angle B. Right. So next we move on to the next question. Question number 3. And this question says, if sine alpha plus cos beta, if sine alpha plus cos beta is equal to 3 by 5 and cos alpha plus sine beta is equal to 4 by 5, we have to find the value of cos alpha sine beta. This is a pretty straightforward question. However, you should not do something arbitrary. You basically don't try to find the values of each of the sine alpha, cos alpha, sine beta, cos beta. That is not the correct strategy here. You don't have to try to solve for each of the terms, right? What we will do is we'll call this 1 and we'll call this 2, these two equations. The standard technique is squaring and adding. If you square 1 and 2 and add them, right, what we'll end up getting is sine square alpha plus cos square alpha, which is 1, plus cos square beta plus sine square beta, which is also 1, plus 2 sine alpha cos beta plus 2 sine beta cos alpha. This becomes 2 plus 2 sine alpha cos beta is equal to basically 9 by 25 plus 16 by 25, which is 1, right? Which implies that sine alpha cos beta plus cos alpha sine beta. I missed that. So you are getting basically 2 plus 2 times sine of alpha plus beta is equal to 1, which implies that sine of alpha plus beta is equal to minus half. So this is the first result that we have gotten. If you do 2 square minus 1 square, in that case, what you will end up getting is cos 2 alpha minus cos 2 beta, using the formulas of cos 2 alpha being cos square alpha minus sine square alpha. So you should do the simplification yourself, and you also get plus 2 sine beta minus alpha. Plus 2 sine beta minus alpha, this is equal to 7 by 25, which comes because 16 by 25 minus 9 by 25, right? So this relation is coming from here, And if we use the formula for cos C minus cos D here, we write it like this. You get minus 2 sine alpha plus beta multiplied by sine alpha minus beta minus 2 sine alpha minus beta is equal to 7 by 25. Now, because we know sine alpha plus beta is minus half, this becomes minus 2 into minus half becomes plus 1. And you end up getting sine alpha minus beta minus 2 sine alpha minus beta, which basically gives you the value of sine alpha minus beta. And that comes out to be minus 7 by 25. So we now know this. We also know this. We just have to find cos alpha sine beta. And cos alpha sine beta is basically the difference, half of the difference of sine alpha plus beta minus sine alpha minus beta. If you expand this and expand this, you will get that cos alpha sine beta comes as half of the difference, which is basically after putting the values, you will get minus 11 by 100. So very straightforward question, but you have to remember that this is a standard technique. Take this equation square and add, and sometimes even subtract, right? So use that technique to get this solution. Let's look at the next one. Question number 4. This is also a pretty common problem, pretty standard and old problem. Prove that you have cos of 2 pi by 2n plus 1 plus cos of 4 pi by 2n plus 1 and so on till cos of 2n pi by 2n plus 1 is equal to minus half. Here n is a natural number. N is a natural number, right? So in this case, you can see that all the angles are varying and there is a common difference. So first there was 2 pi by 2n plus 1, then there was 4 pi by 2n plus 1. The next term would have been 6 pi by 2n plus 1. So if I take alpha as pi by 2n plus 1, the series basically looks like S is equal to cos 2 alpha plus cos 4 alpha, so on, plus cos 2n alpha, right? Now, there is a standard technique for this, and you will realize it once we do it. So what we do is multiply both sides by 2 sine alpha. 2 sine alpha into S. Okay. So why are we multiplying by 2 sine alpha? Because we will be able to split each term and write it as a difference of 2 terms. So what happens here? It becomes 2 sine alpha cos 2 alpha plus 2 sine alpha cos 4 alpha and so on till 2 sine alpha cos of 2n alpha, right? Now, what is this? Think about it. This is basically the difference between sine of 3 alpha minus sine of alpha. How? Because sine of 3 alpha can be written as sine of 2 alpha plus alpha, which is basically sine 2 alpha cos alpha plus sine alpha cos 2 alpha. And similarly, sine of alpha can be written as sine of 2 alpha minus alpha, which is equal to sine 2 alpha cos alpha minus sine alpha cos 2 alpha. So when I subtract this and this, I end up cancelling these two terms and I get 2 sine alpha cos 2 alpha, which is what was there, right? So basically, I'm writing it as a difference of 2 sines, right? Similarly, here also, I can write it again as a difference of 2 sines. It will be sine of 5 alpha minus sine of 3 alpha. Because 5 is 4 plus 1 and 3 is 4 minus 1. It's the same step, you just keep doing it. And here, last term would be sine of 2n plus 1 alpha minus sine of 2n minus 1 alpha, right? Now, what happens as a result of this? You can see that because of the telescoping nature, sine 3 alpha gets cancelled here, sine 5 alpha will get cancelled with the next term, and so on. So what we'll end up getting is just the greater angle of the last term and the smaller angle of the first term. So you will eventually, you can check yourself, it will become sine of 2n plus 1 alpha minus sine alpha, right? Now that is really nice because we know that alpha was pi by 2n plus 1 Therefore, 2n plus 1 alpha is equal to pi. So this is simply sine pi minus sine alpha. So basically, this is equal to minus sine alpha. Now, if this is equal to minus sine alpha, this series was equal to 2 sine alpha into s, and therefore s is equal to minus sine alpha by 2 sine alpha, which is minus half. So we have proved that the sum of this series is minus half. And remember the method by which we proved it? We multiplied it with sine theta twice, sine alpha, and basically did a telescoping series method where we're expressing each term as the difference of two terms, right? The question is normally framed in terms of an evaluation problem, these types of questions. So for example, for n is equal to 3, we can write this identity as cos of 2 pi by 7 plus cos of 4 pi by 7 plus cos of 6 pi by 7 is equal to minus half. So usually in the questions, you will find it, they will just give you the left-hand side and they will ask you to find the value of it. The method is this. Sometimes you might also encounter a formula for evaluating these. So a general formula for this is available in standard trigonometry texts. For example, SL Loney has a formula for any sequence of sines or sequence of cosines where the angles are in AP. However, we will not get into the formula because they are not super important from an Olympiad perspective. The standard method for solving it is what we have just done. So you should keep that in mind. Let's move on to the next question. Question number 5. We are given that let ABC be the angles of a triangle. Suppose a real number x. Suppose a real number x satisfies the equation. And the equation is cos cube x plus cos of x plus a, cos of x plus b, cos of x plus c is equal to 0, right? We have to prove that 1, tan x is equal to cot a plus cot b plus cot c. And 2, we have to show that secant square x is equal to cosec square a plus cosec square b plus cosec square c. Now, this is a tricky problem because of the fact that the expression here is a little difficult to simplify. This expression is a little difficult to simplify. However, keep in mind the way we approach this question and see what we do. So, first of all, we'll write this as cos cube x plus, we'll expand this a little bit and we'll see what it looks like. Cos x cos a minus sin x sin a and multiplied by cos x cos b minus sin x sin b. And this is cos x cos c minus sin x sin c equal to 0, right? Now, the first thing that I want you to realize here is that cos x is equal to 0 is not a solution of this equation. Why is that true? If you put cos x as 0, you will end up getting a situation because cos x is 0, then sin x will be 1. So you will end up getting a situation, this is 0, this is 0, this is 0, this is 0. And you will end up getting simply this is 1, 1, 1. So it will be sin A, sin B, sin C is equal to 0. Now sin A, sin B, sin C equal to 0 means at least one of the angles ABC must be 0 or must be a multiple of pi. But that is not possible in any real triangle. You cannot have an angle of a triangle becoming equal to 0 or pi, right? So cos x is equal to 0 is not a solution of this equation. Therefore, we can divide by cos x, right? Since cos x is equal to 0 is not allowed, we can divide by cos x. And now what I will divide here by is not cos x, I will actually divide by cos cube x. So dividing this by cos cube x, I will get 1 plus each of these 3 brackets, I will divide by 1 cos x. A single cos x divides each of the brackets because overall I have to divide by cos cube x. So this becomes cos A minus tan x sin A, cos B minus tan x sin B, and cos C minus tan x sin C equal to 0, right? Now, since sin A, sin B, sin C are also not 0, I can also divide both sides by sin A, sin B, sin C. So what I will get is 1 by sin A, sin B, sin C, 1 by sin A, sin B, sin C, plus here I will get cot A minus tan x, cot B minus tan x, and cot C minus tan x, right? Equal to 0. So this is the equation which is coming after I divided by cos cube x and I divided by sin A, sin B, sin C. Now what I want to do is take all of these terms. These are the terms that have x. I want to take them on one side and I want to keep this on the other side, right? So if I take them on the other side, I'll have a negative sign. And if I reverse the order of each of these brackets, instead of cot A minus tan x, I want to write it as tan x minus cot A and tan x minus cot B and tan x minus cot C. Then that gives an additional negative sign. So the two negative signs will become positive and you will end up with this equation that I will write on the next screen. You will end up with an equation like this. Tan x minus cot A, tan x minus cot B, and tan x minus cot C. This is equal to 1 by sin A, sin B, sin C. I hope you understand this. You can simplify it yourself and check whether this is coming or not. It should come for you, right? Now, what we will do is we'll actually just expand this. If you just expand it, it becomes tan cube x minus cot A plus cot B plus cot C into tan square x plus the sum of the cot 2 at a time, right? Cot A, cot B. Sum of these cots 2 at a time. There will be 3 terms. I'm just not writing it because of I don't want to write so much. This is tan x. And finally, there is a minus cot A, cot B, cot C. Minus cot A, cot B, cot C is equal to 1 by sin A, sin B, sin C. This is what I'm getting, right? Now, in a triangle, there is an identity that cot of A, cot of B plus cot of B, cot of C plus cot of C, cot of A is equal to 1. This is a very straightforward identity. You just use the fact that A plus B plus C is equal to pi and take tan on both sides after doing tan A plus B is equal to tan of pi minus C and expand it and you will be able to show that tan A plus tan B plus tan C is equal to tan A, tan B, tan C. This is a standard proof there in every trigonometry textbook. So tan A plus tan B plus tan C is equal to tan A, tan B, tan C. And if I divide both sides here by tan A, tan B, tan C, I will end up getting this identity. So because of this identity, this term is 1, right? So therefore, I can write it as tan cube x minus sum of the cot A's into tan square x plus tan x is equal to, I bring this on the other side, it is cot A plus cot B, cot A, cot B, cot C plus 1 by sin A, sin B, sin C. So this becomes 1 plus cos A, cos B, cos C by sin A, sin B, sin C. Right? This is what we are getting here, right? We are getting this expression. What have I done here? I have taken this on the other side and I've just written all the cots as cos by sin. If you do that, you will get 1 plus cos A, cos B, cos C by sin A, sin B, sin C. Now, there is one key step here where we will be utilizing our knowledge of triangles. So let's see what is the value of cot A plus cot B plus cot C. Let's try to simplify that, right? So let's call K is equal to cot A plus cot B plus cot C, right? And now this can be written as cot A plus this is cos B by sin B plus cos C by sin C. If you write it like this, cot A plus, if you take common denominator, it is sin B sin C. And on top, it will become cos B sin C plus cos C sin B, which is sin of B plus C. Right? And now, You can write this as cos A by sine A, cos A by sine A, plus this is sine B plus C, which is sine A by sine B sine C, right? And then you can take common denominator, it becomes sine A sine B sine C. And on top you have cos A sine B sine C plus sine square A, right? Because I'm just simply adding the two fractions. Now, sine square A can be written as 1 minus cos square A. So we can write this as 1 plus cos A sine B sine C minus cos square A, right? Divided by sine A sine B sine C. Now, taking cos A common between these two terms, I'm getting 1 plus cos A common, and I'm getting sine B sine C minus cos A, and cos A, okay, I'll just write it, minus cos A, right? Divided by sine A sine B sine C. Now, what is this term, this thing inside the bracket? If you think about it, in a triangle, cos A is equal to negative of cos of B plus C. Because A is equal to pi minus B plus C, so cos A is equal to negative of this. And if you expand this, this becomes minus cos B cos C plus sin B sin C, right? So cos A is equal to this. So negative of cos A will be cos B cos C minus sin B sin C. So minus sin B sin C will cancel this sin B sin C. So you will end up getting 1 plus cos A multiplied by cos B cos C, right? Divided by sin A sin B sin C. Why is this important for us? This is important because what we are getting is that cot A plus cot B plus cot C is equal to this term, and this term was on the right hand side, right? So basically we are saying that this is equal to this, right? So that means that the equation becomes like this: tan cube x minus k times tan square x plus tan x is equal to k. Here k is called cot A plus cot B plus cot C. And we have just now proved that this is equal to 1 plus cos A cos B cos C by sin A sin B sin C. Correct? So notice how the equation has become so much simpler. So here we can take tan square x common, and it is tan x minus k, plus bring the k on one side, and it is tan x minus k equal to 0. So we have basically factorized the whole thing, and it is tan x minus k tan square x plus 1 equal to 0, which implies that tan x is equal to k. And tan x is equal to k means tan x must be equal to cot A plus cot B plus cot C. Right? This is the first inequality that we were asked to prove. So we have already proved that tan x is equal to cot A plus cot B plus cot C. If you take squares here at this stage, take squares, tan square x will become cot square A plus cot square B plus cot square C plus 2 times the sum of the cots taken 2 at a time, product of the cots taken 2 at a time, which is cot A cot B plus cot B cot C, but that is equal to 1 for a triangle. We have already showed that earlier. So we have this. So if you do 1 plus tan square x, that will become 3 plus cot square A plus cot square B plus cot square C, right? And that can be written as 1 plus cot square A plus 1 plus cot square B plus 1 plus cot square C. And this side, this becomes sec square x. And this becomes cosec square A by identity, and cosec square B and cosec square C. So this is the second identity that we are asked to prove. This plus this plus this, right? So the key part of the problem was simplifying the equation intelligently and realizing that the equation becomes basically this equation: tan x minus k into tan square x plus 1 is equal to 0, which implies that tan x must be k, and k was cot A plus cot B plus cot C. So this question tests whether you can basically simplify formulas properly and long expressions properly or not. So hopefully you all learned something from this video. from this particular problem. We'll go to the next one now. Question number 6. In this question, we have let ABC be an acute triangle. Acute triangle. We need to show that tan A plus tan B plus tan C, tan A plus tan B plus tan C is greater than cot A plus cot B plus cot C. It's a pretty straightforward problem. However, you need to realize certain things. You need to realize that the tan function is increasing or is monotonic on 0 to pi by 2, on 0 to pi by 2 interval, right? And since it is an acute triangle, all the angles of the triangle are lesser than pi by 2, right? Therefore, we can say C is greater than 0 and C is less than pi by 2. And because of that, 0 is less than C is less than pi by 2. I can write C now as 0 is less than pi minus A plus B is less than pi by 2, right? So therefore, we get A plus B is greater than pi by 2. If I take these two and simplify, I'll get A plus B is greater than pi by 2, which implies that A is greater than pi by 2 minus B, right? So basically, the order of the angles must be 0 is less than pi by 2 minus B is less than A is less than pi by 2. Because it is an acute triangle. This is the order of the angles, right? So if you have this situation, if I take tan on both sides, I will get tan A is greater than tan of pi by 2 minus B. Because tan is an increasing function. So if the angle is greater, the tan is greater. So we can show here that tan A is greater than cot B. Because this is a complementary angle, tan pi by 2 minus B is equal to cot B. So we have proved that tan A is greater than cot B. And in a similar manner, by taking a different angle, we can show that tan B is greater than cot C. Tan B is greater than cot C. And we can also show that tan C is greater than cot A. So that implies that the LHS, which is tan A plus tan B plus tan C, must be greater than cot A plus cot B plus cot C. A pretty simple question, but we are using again the fact that tan function is increasing and also that the triangle is acute. So we get the ordering of the angles A and pi by 2 minus B, from where it is following that tan A is greater than cot B. Let's look at the next one. Question number 7. Another inequality problem. We have let X and Y be acute angles and tan X is equal to 3 tan Y. 3 tan Y. We have to show that X minus Y is less than equal to pi by 6. Okay. So if tan X is equal to 3 tan Y, then obviously it implies that tan X is greater than tan Y, since X and Y are acute angles, and in the acute angles range, tan X and tan Y are both positive. So this is true, which implies that X is greater than Y, right? Because tan is an increasing function, so X is greater than Y, and we have X minus Y greater than 0. So that is at least one bound on X minus Y, but it's not the thing that we need to prove, right? So for that, we will say tan of X minus Y is equal to tan of X minus tan of Y by 1 plus tan X tan Y. This is from the formula of tan A minus B. And now this we can write, since tan X is equal to 3 tan Y, we can write it as 2 tan Y. 3 tan Y minus tan Y is 2 tan Y by 1 plus, instead of tan X, again I write 3 tan Y. So it is 3 tan square Y, right? We get this. And now we'll use A and GM and we'll say 1 plus 3 tan square Y is greater than equal to twice of root 3 tan Y. This is A and GM on these two terms. So therefore, tan of X minus Y, which is equal to 2 tan Y by 1 plus 3 tan square Y, will be less than equal to 2 tan Y by 2 root 3 tan Y. Why? Because the denominator is greater than equal to 2 root 3 tan Y. So the overall fraction will now become less than equal to this because it is in the denominator, right? So here we can cancel the 2 tan Y and the 2, and we get basically tan of X minus Y is less than equal to 1 by root 3, which implies that X minus Y is less than equal to pi by 6. Because again, tan function is monotonic and increasing. So when you have an inequality, you can just say statements about the angle itself, right? So that's it for this one. Let's look at the next problem. Question number 8. Here, if A, B, C are angles of a triangle, we have to show that sine of A by 2, sine of B by 2, and sine of C by 2 is less than equal to 1 by 8. This is a very standard inequality. The equality happens when the triangle is equilateral. So how do we prove that? So for any triangle ABC, we can say that A by 2, B by 2, and C by 2 add up to 90 degree. Therefore, sine of A by 2 is greater than equal to 0. Actually, it is not even equal to 0. It will always be greater than 0 because the angle cannot be 0. Similarly, sine B by 2 is greater than 0 and sine C by 2 is greater than 0. So all the three signs are positive quantities, right? Now, let's look at the product. Sine A by 2, sine B by 2, sine C by 2. We can say that this is equal to half of sine A by 2 and multiply it by 2. So 2 sine B by 2, sine C by 2. And we can write the 2 sine B by 2 sine C by 2 as the difference of cosines. We can write it as half of sine A by 2 cos of B minus C by 2 minus cos of B plus C by 2, right? This is an equality. This is an identity that will be obvious to you if you expand these two. Cos C minus cos T will be this, right? Now we are saying that this stuff will be less than equal to half of sine A by 2 and instead of this, I can write 1 minus cos of B plus C by 2, right? Why? Because obviously cos B minus C by 2 is less than equal to 1. So I can replace it with an inequality now. So we get this, and cos of B plus C by 2 is basically sine of A by 2. Because B plus C by 2 is 90 minus A by 2. So cos of 90 minus A by 2 becomes sine of A by 2. And we have this, right? We have this inequality. Sine A by 2, sine B by 2, sine C by 2 is less than equal to half into sine A by 2 into 1 minus sine A by 2. Now, let's look at this function here. This is like a function x into 1 minus x, right? Where x is sine A by 2 and we have x sine A by 2 into 1 minus sine A by 2. So if you look at this function, this is x minus x square, which can be written as 1 by 4 minus 1 by 4 plus x minus x square, which can be written as 1 by 4 minus x minus half whole square, right? So we can say that x into 1 minus x is always less than equal to 1 by 4, right? Because it is 1 by 4 minus a perfect square, right? So that implies that this part is always less than equal to 1 by 4. So you get sine A by 2, sine B by 2, sine C by 2 will be less than equal to 1 by 2 into 1 by 4, which is equal to 1 by 8. So that is what we wanted to prove, right? So what are we using here? We are using the fact that cos function is bounded by 1. And then we are using the fact that this looks like an inequality. This looks like a quadratic expression, x minus x square, which has an upper bound of 1 by 4. And we use those two facts together to prove that this is less than equal to 1 by 8. And when does equality happen? Equality happens when actually this is equal to 1 by 4, which happens when x is equal to half. And when is x is equal to half? Then sine A by 2 is equal to half, which A by 2 is pi by 6 and A is basically pi by 3. So that shows that when angle A is 60 degree, that time it is happening to be equal to 1 by 8, right? So that means that is an equilateral triangle case, right? Okay. The next one that we look at is basically this. Question 9. We have, suppose the inequality, and the inequality is given as sine 2 theta minus 2 root 2 a cos theta minus pi by 4 minus root 2a by sine theta plus pi by 4 is greater than minus 3 minus a square. Suppose this inequality is satisfied for all theta belonging to 0 to pi by 2, right? We have to find the range of A. Find the range of A. Okay. So we have to find the range of the parameter A if this inequality is always true, right? For all theta belonging to this range. Now this problem will become very easy if you just take a simple substitution. Let's say x is equal to sine theta plus cos theta. So if x is equal to sine theta plus cos theta and theta belongs to 0 to pi by 2, that implies in that range, the minimum and maximum value of x is x belongs to 1 to root 2. That is standard enough that I will not bother to explain that. You can write this as root 2 times sine of theta plus pi by 4. And you will get the fact that maximum value of this is root 2. The minimum value is 1. And you can check that with putting some values and all, right? So x belongs to 1 to root 2 in this range. And we can say sine 2 theta is equal to basically x square minus 1. If you square this, it will become 1 plus sine 2 theta. Basically, that is equal to x squared. So therefore, sine 2 theta is x square minus 1. Cos of theta minus pi by 4 is equal to basically x by root 2. Why? Because this becomes what? This becomes cos theta 1 by root 2 plus sine theta 1 by root 2. And this is also equal to sine of theta plus pi by 4. So the inequality can be simplified now and written in terms of x. And if you write it, it looks like this: x square minus 1 minus 2 root 2a x by root 2 minus root 2a by x by root 2, right? And greater than equal to minus 3 minus a square. So if you write it again a little bit more, this becomes minus 2ax minus 2a by x is greater than minus 3 minus a square. So this is my inequality right now. Here x belongs to 1 to root 2, right? Now I rework it on the next screen. So what you will get is basically this: x square minus 1 minus 2ax plus 3 plus a square minus 2a by x is greater than 0. I have brought the terms on the right hand side to this side, right? And if you rewrite it here, this can be written as x minus a whole square, because there is x square minus 2ax and a square, plus 2 times x minus a by x. How am I getting that? I'm getting it from basically 3 minus 1, 2, 2 minus 2a by x. That is equal to this, is greater than 0. Now, if you solve this, you'll get x minus a common, and you'll get x minus a plus 2 by x greater than 0. And rewriting it with taking the minus sign, replacing the order of these terms, you can get it as a minus x multiplied by a minus x plus 2 by x is greater than 0. This is the final form of the inequality, right? Now here, this function f of x is equal to x plus 2 by x is decreasing when x belongs to 1 to root 2. Why? You can check f dash x. F dash x is 1 minus 2 by x squared. You can check that when x lies between 1 to root 2, f dash x is less than 0. So that shows us that this function is decreasing. If it is decreasing, the maximum value of f max, will be at f of 1 will be 3, and f min will be at f of root 2. And we don't actually care about that particular value. It is actually going to happen when root 2 plus root 2. So it is 2 root 2. But the f maximum value is 3, right? And it happens that x is equal to 1, right? Great. Now, we can see that this inequality, if I say x is equal to 1, and if 1 belongs to a is less than 3, if a lies in this range 1 to 3 and x is equal to 1, then what is happening is this inequality is not greater than 0. It actually becomes equal to 0. If a lies in this range, either it is equal to 0 or it is negative. Why? Because a minus this 3, it becomes a minus 1, a minus 3. It is either equal to 0 or less than 0 if a is between 1 to 3, right? You can confirm that yourself. If a is between 1 to 3, this inequality, this term is negative, this term is positive. So they're either less than 0 or equal to 0, right? So the inequality will not be satisfied if a belongs to this, right? And x is equal to 1. Now, if a is less than 1 or a is greater than 3, right? If that is the situation, for example, let's take a is greater than 3. In that case, the inequality is a minus x plus 2 by x, right? Now think about it. X belongs to 1 to root 2, but a is greater than 3. Therefore, a minus x belongs to 1 to root 2. And a is greater than 3. So a minus x will be positive. And when x belongs to 1 to root 2, this function values will decrease from 3, right? The maximum value of the function was 3, but after that it is going to become lower than 3, right? So this is also positive. So the overall inequality is satisfied. It is greater than 0 for this range of x if a is greater than 3. Also, if a is less than 1, what will happen? If a is less than 1, this part is negative and this part is also negative, right? If a is less than 1, you have x plus 2 by x will be between 3 and 2 root 2, right? 3 and 2 root 2, and a is less than 1. So this is also negative. This is also negative. So again, the whole inequality is satisfied. Therefore, what we are getting is that the range of values of a for which this inequality is true for all x lying in this range is basically minus infinity to minus 1 to plus 1 and union 3 to infinity, right? So a should belong to this set. A should be less than 1 or a should be greater than 3, in which case this inequality is true for all values of x. So that's how we solve it. We have converted the trigonometry problem into an algebraic inequality problem. That was the key idea for this. And once you do that, it is sort of over, right? Okay, let's look at the next question. This is question number 10. Yeah, here we have to show that for each natural number n, we have to show that tan power na plus tan power nb plus tan power nc is greater than 3 plus 3n by 2, where this is ABC are the angles of any acute triangle ABC. Okay, right. So for an acute triangle, we have to show that this inequality is true, right? Okay. So for the triangle, we have already seen in a previous problem that cot A cot B plus cot B cot C plus cot C cot A is equal to 1, right? We already know that this is true for any triangle actually. Now, if I apply A and GM inequality to this, right? What I will say is sum of cot A cot B divided by 3 is greater than equal to the cube root of the product of these three terms, right? So that will be cot A cot B cot C whole square, right? And the sum is actually 1. So we get basically 1 by 3 is greater than equal to cot A, cot B, cot C to the power 2 by 3, right? Great. So if I take roots, I will get 1 by root 3 is greater than cot A, cot B, cot C to the power 1 by 3, right? Okay. Now, if I write this as this cot A, cot B, cot C, I can write as 1 by tan A, tan B, tan C and take this on the other side. I will be able to prove that tan A, tan B, tan C to the power 1 by 3 is greater than √3, right? This is the identity that I wanted, because now I can connect this stuff to this, right? By AMGM again, obviously. So let's apply AMGM on tan power NA, tan power NB, and tan power NC, because we are guaranteed that A, B, C are acute angles, so tans are positive, so we can apply AMGM. So we can say that this stuff will be greater than equal to 3 times the cube root of tan A, tan B, tan C power n. This is power n, and this is outside is 1 by 3, right? So basically, this is tan A, tan B, tan C power 1 by 3, and outside you can keep the n power, right? It's the same n by 3 power. And now we already know that this is greater than equal to √3. So this is greater than equal to 3 √3 power n, right? I hope you are understanding what we are getting. We are establishing the AMGM inequality here and using the condition that we have already shown, right? So we are getting that this is greater than equal to 3 √3 power n, right? Now we still have to show this. However, that is pretty easy. So we have so far tan power NA, tan to the power NA, and tan power NB plus tan power NC is greater than 3 √3 power n. And now we can say that this is greater than √3 is 1.732. So I can write it as greater than 3, 1 plus 1 by 2 power n, right? Because 1 plus 1 by 2 is simply 1.5. So it is obviously true, right? So this is equal to 3, and using binomial theorem, this is greater than equal to 3, 1 plus n by 2. Ignoring all the future terms, if you just take the first two terms of 1 plus half to the power n, it is 1 plus n by 2. That is equal to 3 plus 3n by 2, right? And we have basically established the set of inequalities here. Tan power NA, the sum of these three terms is greater than this, right? So basically, we are repeatedly using ANGM, and we are also using the identity cot A, cot B, cot C, product of them two at a time was equal to 1 for any triangle, right? Okay. The next problem is basically this question. We have question number 11. Let x and y be real numbers such that x square plus 2 cos y is equal to 1. And we have to find the range of x minus cos y. Okay, so we are given this condition and we have to find the range of this expression. So let's try to simplify this. We want this x minus cos y to come in terms of only one variable. I don't want to do a range of x and y variables, right? So I need to remove the cos y somehow. So I can easily say from here, x square is equal to 1 minus 2 cos y. So that implies that x square should belong to the set 1 minus 2 cos y will range from -1 to 3. And therefore that implies that x should belong to minus √3 to √3, right? That is the first level approximation that we are getting. X belongs to minus √3 to √3. Also, we know that cos y is equal to 1 minus x square by 2. Therefore, x minus cos y starts looking like x minus 1 minus x square by 2, right? So that is basically x plus x square by 2 minus half. And that can be written as half common. This is 2x plus x square plus 1. And you subtract a half, so it becomes minus 1. So this is x plus 1 whole square by 2 minus 1, right? So x minus cos y starts looking like this, which means that the minimum value of this x minus cos y will happen when this is 0, right? Minimum of x minus cos y will happen when the quadratic, the squares is 0, right? So is equal to -1, right? And that happens at x is equal to -1, And the maximum will happen when this is as large as possible. When will that happen? When x is equal to root 3, right? Because x range is minus root 3 to root 3. So when x is equal to root 3, you'll get 1 plus root 3 whole square by 2 minus 1, which becomes 1 plus 3, 4 plus 2 root 3 divided by 2. So that is 2 plus root 3 minus 1, which is 1 plus root 3. So the maximum value of this is becoming 1 plus root 3. So what we will say, the range of the parameters that we want, range of this is coming out to be minus 1 to root 3 plus 1. Again, pretty straightforward problem. I hope you have understood the techniques that we are using so far. We are using functions, we are using inequalities, we are using simplification of trigonometric expressions using formulas, and we are using some triangle identities. There are some more things that I would like to discuss, but it will probably be pursued in a later section. When we do a little bit of geometry, I'd like to discuss some more problems. Those problems will involve cosine rule, sine rule, and some inequalities pertaining to triangles. But we'll do that later in a section devoted to the geometrical points about a triangle. So this concludes our basic review of trigonometry. I hope the video helps you get in touch with all the trigonometric techniques. You should definitely try and solve all of these questions on your own. Don't just glance through the solutions. You should try it yourself, and then only you will be realizing what techniques we have used and whether you can apply it and whether you have truly learned it or not. So that's it for this section, and we'll move on to the next part of the course from the next video. I'll see you in the next one.